Hello friends, in today's question, a vibrating string of certain length L under tension T resonates with a mode corresponding to the first overtone, that is third harmonic, of an air column of length 75 cm inside a closed tube at one end. The string also generates 4 beats when excited along with a tuning fork of frequency N. Now, when the tension of the string is slightly increased, the number of beats reduces to 2 per second. Assuming the velocity of the sound in the air to be 340 meter per second, the frequency N of the tuning fork in hertz is. So in this case, we are supposed to find out what will be the frequency of the tuning fork, or we can say value of N. And it is given that the string resonates at the same frequency with as the air column. Okay. So let us find out first of all the resonance for air column. From there we can you can say also find out what will be the resonant frequency of the string, and then we are going to write the equation for beats and then the further solution. So let us start from there only. The resonance of an air column and it is given that the tube is closed at one end. So we are given that tube is closed at one end, therefore only odd harmonics are allowed. So only all odd harmonics are allowed. Therefore, we can write the equation that the frequency of the air with respect to air rather, because there is an air column and there is a string. So we are going to write for this air column, frequency for the air column will be equal to N times V divided by 4L, where value of N will be odd, that is 1, 3, 5 and so on. V is the velocity of the sound in the air. V is the velocity of sound in air, and L is the length of the tube. Length of tube. And it is given that the air column resonates at first overtone, that is third harmonic. So we are given the air column resonates in its first overtone, that is third harmonic, that is third harmonic, giving us value of N will be equal to 3. So we substitute all the values, we get F air will be equal to 3 multiplied by 340, and we have 4 times multiplied by the length. Length is given as 0.75. So this comes as 340 Hertz. So the air column resonates at 340 Hertz, and in the question itself it is given that vibrating string resonates with the air column. So it is given that the vibrating string resonates with air column Therefore we can say that F for string will be equal to F for air, which we already found out, and this will be equal to 340 Hertz. Okay, this was the first part, and in the second part it is given that the string produces the beats. Okay, so in the first part it is given the string produces the beats, 4 beats, when the tune to the frequency of tuning fork, and the tuning fork frequency is given as n. So therefore we can write that string produces beats of 4 when, not when, but with, sorry, with a tuning fork of frequency n, with a tuning fork of frequency n. So we can write the equation that this gives us frequency of string minus value of n, and its modulus will be equal to the beats, number of beats, that is equal to 4. Okay, now it's also mentioned that let's solve this first of all, then we can come to the later part in which it is given or mentioned that the string undergoes a tension, and because of this the beats reduces to 4. Okay. So let us call this as initial condition. This we call as a initial condition. So this can be written as that our F string can be either equal to n plus 4 or F string can be either equal to n minus 4. And we already know the value of F string is our 340. So therefore from here we can say that either the value of n will be equal to 340 plus 4, or value of n will be equal to 340 minus 4. So this gives us that the value of n will be either 344 or value of n will be either will be equal to 336. So these are the two possible values for n. So please keep in mind that it is only given that the beats of 4 is being produced. Therefore the beats 4 means the string can be, it can be F string minus n, or it can be like here I written, this part, it can be F string can be equal to n plus 4, or it can be F string can be n minus 4. So beat can be plus minus, both additive as well as subtractive on the both side, positive as well as negative side. So this gives us, or this narrows us, that we have only two possibilities for n, that is either 344 or 336. So if we check the options that are given to us, these two options, that is C and D, will not be the answer. Only possibility is that either A will be the answer or B will be the answer. Now we are going to solve it or try to troubleshoot it or find out whether A will be answer or whether B will be the answer. Okay, and for that we are going to do it in two ways. In the first part, we are going to say that the number of beats are reduced to 2 beats per second, 2 per second rather. Okay, this will be helpful in finding out one of the value. So we come to the important part, and that important part is that to determine the value of n. To determine the value of n, that is it either 344 or it will be 336. And for this we are going to rely that the effect of increasing the tension. Okay, so we say that we rely on the effect of increasing tension in the string and observe the change in the beat frequency. And observe the change in beat. So we already know the relationship between the tension and the frequency. Okay. So we say the relation between tension, which is given as capital T, and frequency, which is represented as F, and this relationship is our F is directly proportional to square root of T. So which basically means as tension increases, the string frequency is also going to increase. Okay. So from here you can say when tension increases, string frequency which we are going to write as F string also increases. Therefore, this F string, after the increase of the tension, we are going to call this as new tension with the help of the new notation. We are going to call this as F string new, and this F string new will be greater than frequency of F string. Okay, I forgot to write it here. This will be over new. So it means F string new is the frequency when the tension has been increased. Okay, so it means as the tension increases, the string frequency, which is represented as F string nu, also increases. Therefore, the value of F string nu will be greater than F string. And F string we already found out is our 340. Therefore, we can say that F string nu will be greater than 340. Okay. So, next, it is also given that as the tension increases, the number of beats are reduced to 2. Okay. So from here also, we can say new beat frequency reduces to 2 beats per reduces to 2. Therefore, we can write it as F string nu minus n. This comes equal to 2. So which basically means that the new frequency of the string, which is represented as F string nu, moves closer to n because the value has been reduced from 4 to 2. So from here we can draw one important conclusion, that new frequency of string, which we wrote as F string nu, moves closer to n. Moves closer to n after tension increases. After tension increases. So let us discuss both the cases. We have two values. Case number 1, the value of n is our 344. So before increase in tension, that is initial, we can write before tension increase, which we called as initial, the equation is given as F string minus n will be equal to 4. So we know already value of F string. F string we know is 340. Value of n is our 344. This should be equal to 4. So therefore, if you solve it, becomes left is equal to right. Okay. So therefore, we can say this is consistent . Okay. So this is consistent in the first part. In the second part, after tension increases. After tension increases, that is our final, and we know the equation that the F string nu minus n should be equal to 2. And n we know is our 344. Okay. If we substitute here, put n is equal to 344. So we are going to get two values. One value will be f string new will be equal to 346, or that will be equal to 342. So these are two values when we put n equal to 344 in this equation. And we just also concluded here that the f string new should be greater than 340. Okay, let us call this as equation number 1. So we are going to test it here. We can say that from equation 1, f string new should be greater than 340. So if we check both the values, these both values are greater than 340. Okay. So here also we can say the results are consistent. You can say this is consistent. Okay. Now let us check the second part. So at least from here we can say discussing this part, we can at least draw a rough estimate, a rough conclusion that the n is equal to 344 can be the answer. 50% we are very sure about. 50% you can say more than 50% because we have only two options. So either A will be 50% and B will be 50%. Okay. Now let's check, because it can be multi-correct also. So let us check the case 2 also. We can say case 2, and case 2 value of n is our 336. So once again we are going to do it for initial condition. And initial condition we know is our f string minus n is equal to 4. F string we already know, the value is our 340. So this gives us 340 minus 336 is equal to 4. So therefore we get 4 is equal to 4. This is also consistent. Now let us check for the after increased tension. This was our initial condition. Now let us do same thing for a final condition. Final condition means when the tension has been increased. So for final condition, the equation is our f string new minus n, and the beats are given as 2. So from here we know already value of n, so we can say put n is equal to 336. So this gives us f string new will be our 338, or it will be 334. But once again, the f string new should be greater than 340 as per equation number 1. Okay. So you can say, but from equation 1, f string new should be greater than 340. Here the inconsistency arises. Okay. So you can say this is inconsistent. This is inconsistent. Therefore, we can say that the value of n value of n will be equal to 344. Now there is another way so that we can further verify whether this particular result, which we just found out that value of n should be equal to 344, is still valid or not. Okay. So let us try solve it further also. So we know that as the f string increases to f string new, the number of beats reduces from 4 to 2. So it means if n is greater than f string, therefore we can say that 344 is greater than our 340. Okay. And we can say that is increasing f string to f string new reduces our beat, that is given as f string new minus n, that is reduction of beat from 4 to 2, that is reduction of beat from 4 to 2. And for second value of n, which was our 336, in that case n is less than f string. N is less than f string. Value of n is our 336, and which is obviously less than 340. Therefore, we can make a same conclusion that increasing f string to f string new would increase the beat frequency relationship, that is f string new minus n. That is, beat should increase, that is beats should increase, but in the given question it is given that the beats are reducing. Okay, beats should increase, but it is given that beats reduces from 4 to 2. So this also helps in finalizing the answer that the value of n is our 344. If we check the options that are given to us, we can say that the option number A is our correct option. This is our correct option. Okay. So you can write that therefore value of n is equal to 344. Option A is correct. Okay. So please keep in mind that the beat can be positive as well as negative. Okay. So this is important part to keep in mind, that beat can be, it can be upper side also or lower side also with respect to it's not much better to call it a positive and negative. We can just call it, it can be on the upper side also and it can be lower side also. Okay. So this completes the question. Thank you.